Good afternoon, everyone. I'm happy to be here in Yash, I think. It's the right pronunciation. If it's not the case, my colleagues have been making fun of me, so hopefully it's correct. My name is Erwin Manders. I am a solution architect, although I've done Java coding for a long time, and I still like Java coding, even though my employer tells me it's not officially part of my, how do you call it, my work package right now, but I still like to do it, so that's why today I'm going to be talking about test automation here today. I'm a big fan of anything related to testing. Makes our life easier. Hopefully also we can be a bit more lazy than if everything is nicely automated. I work for Rabobank. It's based in the Netherlands, although private banking for us is mostly based only Dutch customers. We do have a lot of international corporate clients. We are mostly called the Farmers Bank. We do a lot of, especially farmer organizations, helping them getting their thing up to speed. We are mostly international in countries like Brazil and Australia, but some other smaller places along the world as well. So the topic of today is going to be how to get rid of chain tests. Why would you want to do that? The way I personally like to develop my code is really making sure I can do releases every day. This is the main goal. I build a feature. I don't want to have to spend 2 weeks in manual tests before I can finally release it. I want it to be in production the same day, basically. This is the goal for today. When I joined Rabobank, this was, of course, not yet the case. There are still, of course, plenty of manual testing, chain testing going on. But first, before I go into the tooling that I have created some demonstrations for an automated testing, something about what we do specifically. When we think about a bank, who thinks about payments? Everybody thinks about payments, mostly when you talk about a bank. Who thinks about platform when they hear a bank? Nobody, right? But that's what we do. We are my colleagues here, they are here as well. We are the Type digital platform. What does that mean? We are responsible for all the platforms. Simone in the previous talk, she talked about black box. We are basically the black box behind the first black box you talked to. We are responsible for everything that from front-end platforms to back-end authentication servers and services to authorization services and anything else that comes to making sure another tribe can provide their product or their feature on our platform. That's what we do. And that comes with a lot of dependencies. The entire bank has dependencies on our platforms. And if something breaks or is tested improperly on our platform, everything breaks. So that's where the idea of involving and investing more in automated testing also comes from, because if we want to release the platform every day, I can't do that by having manual testing that takes me 2 weeks to do, because the bank cannot evolve without the platform evolving. The initial approach when we started with the idea of releasing more often was a little bit of this. We started making more of the same tests. That, of course, doesn't really work very well. If you don't involve any new tooling, any new ideas, upgrading your testing, new ways of testing, then the quality isn't going to go up, and you're not going to have any more trust in your test than that you already have. So the idea of this is really, of course, quality over quantity, because at the end of the day, if I have automated tests that really scope only a very limited type of testing, when my automated test needs to go to the final caption test at the end of the day, it will not pass. So then we are still stuck with the idea of, even though we have done a lot of automated testing, in unit testing more specifically, we still end up doing manual testing because the product owner said, I don't trust what you have built. So what I'm going to be doing today, I have prepared a total of 5 different toolings, technologies to show you that brought us a lot further in the last few years, where I'm thinking like, if you're hopefully you're somewhere in this chain, and you will find one or more toolings where you think like, hey, this is something where I can invest in, this looks pretty interesting, and you can start from there. So not necessarily all 5 at the same time, but depending on where you are, you can always improve. We're going to start with that before we go really into the tooling. We're going to start a little bit about mainly still unit testing part, but it can be used in all types of testing, is the idea of writing your own extensions. Generally, a lot of people like to make their own code reusable, and sometimes we make testing code reusable. But how often do we realize that we can also make this testing code reusable in a way that works natively with the, in this case, the Jupiter API? It's a little bit comparable pre-Jupiter that used to be the same as defining rules, but nowadays I can do a lot more with the Jupiter API than I used to be able to do. So we're going to be showing an example of that, how to do that. By definition, I can write an extension, and it can be defined and constructed as an extension as long as it implements at least one of the 6 testing stages, going from the before all, before each, before test, and the after variants of those. If my testing component implements one of these interfaces, I can then register it as an extension, and it will do those actions every time I run a test that has this extension registered. I can put any code in there that basically implements some step that I would normally test manually, because existing unit testing practices, for example, cannot do this. So I can write something myself. So let's look into the first thing that I have prepared. What I've done here is I have a car factory that obviously returns a car. When I call the drive method, it's a void method, but it does some logging, because when I'm driving my car, it's very important that it keeps track of how many miles there are, and I can't cheat it, so I'm logging it into my log files. But of course, in this case, I can't really do any assertions, because this method of code doesn't return anything. So what I want to do is I want to write, in this case, I'm going to write a demo to you, an extension that it can be very easily added on top of a unit test that just asserts logging for me. So instead of what we used to do is manually sometimes checking, is the logging as I expect it to be, I'm just using a JUnit Jupiter extension to do that for me. So the idea of the log tracker is that 2 things. I have an appender. All the logging that's basically that I register inside my extension goes into the list appender, and it grabs that from a few different sources. So I can say, check this class, check this component, or check this named source. And then run the test, and I can add assertions on the list appender. I expect it to log something like this. So the extension, however, as I said, I need to implement at least one of the interfaces that I mentioned. So in this case, I have chosen to implement 3 of them. What it will do, before every test, it will check the sources that I want to verify what they're logging and add them to the appender. At the end, of course, the entire framework is reset, and before anything happens, the entire framework is prepared and started. It's a little bit of a design choice to start it early, because what I want to do, I want to be able to configure on class level, but also on test level. That's why it's just started early, but the good thing about creating extensions is very simple. If you want to design it in such a way that you can only do it on one of the 2, you just change the before all and only before each, and you have exactly what you want. So this is the added value in this. Just to demo quickly how that looks like. There are 2 ways of registering extensions. Hopefully, as you know, probably most of you do know the add register extension on top. That one I cannot use here. I have to use register extension That is not register extension, that is extend with, of course. The difference is extend with on class level requires a default constructor. That is the only difference. If I need to give it some information before it can do anything, I use register extension. So in this case, what I do, for this class, I want to record all logging that is info or higher, and for my test specifically, I am, in this case, recording for a class type. And what it will do is all the logging that this class type will log. It has a SLF4J log type. No name given, so it will log on the logger of this class. And it will verify for me that if I drive some distance, that it indeed has that logging inserted into my log files. So I don't have to do log checking this way. Of course, I can do also object, and then say log it only for this specific object. The difference, of course, is that if I have two different objects of the same type and I want to know specifically has it been logged by this type, and this would be very useful. And the last thing, which is also possible, I can give the logger a name. I can track it that way as well, but it's not very interesting. It's the same thing as before. It will track only that logger. Know that in this case, a named logger and class, they cannot be done at the same time. Because when I give a logger a name, it is not recognized as this class anymore. But that's really specific about this example. So let's go back here. What have we solved with this problem? At least we're trying to take some extension model, giving us the possibility to go a little bit further than the usual extensions that we have by creating reusable code that does something specifically that I need for my, my code. Number two, this is really the start of writing very extensive integration tests. That is WireMock. I think nowadays almost all our applications have some kind of or a lot of WireMock running in the background doing all kinds of things. If you're having troubles really creating an environment that you normally have in your test environment, creating that in your automated build pipeline, WireMock is really the place to start to say, if I miss something in my unit test and I need to copy that on my test environment, start writing WireMocks and getting them into your automated test. WireMock can really do a lot of things. It's really just a lot more than just writing stubs. If I do this, give me that back. That is, of course, a very simple application, but it really does a lot more. For example, it can do proxies, load balancing, anything like that. But also, since we do authentication service, for example, you have to do signatures. We work a lot with JSON Web Tokens. You can write actions that tells you, hey, I want WireMock to act as the missing authentication server that is normally present there. You can create all those actions and rules inside there. Of course, it also allows you to do that using either XPath or JSON path or all patterns, depending on which type of service you're talking to. So if you have path params or JSON objects coming in and want to say, if I see this value coming in, do that. If I see that coming in, do this. Then, of course, allows you to do that for any kind of service call you're doing. Also, WireMock is really simple to port to your, if you want to run some tests still in your, let's say your test environment or whatever, you can also run WireMock there and still have your entire application running standalone with all these things without the need for physical other service being present. So you can still do this. It's basically the same application. So in very simple ways, how does it look like? Scroll this down a little bit. We're going to look at two things. We're going to look at a very simple stubbing, and we're going to look at how to rewrite proxies in WireMock. So just to start very simply, I have an API that I want to call, and I'm going to tell WireMock if a call happens to this endpoint, the WireMock will currently run on 1990, I have to make sure WireMock and the application that I run, of course, don't run on the same port. I can tell it, hey, return a JSON file for me. In the configuration, there is information on where does it find these files. So what's going to happen here, once WireMock detects an incoming call on 1990, this endpoint, it's going to add headers, it's going to add a fixed delay, it's going to add a status 200. This is optional, but just to show that I can return, of course, any kind of status that I want. And it will turn the JSON in this file null that the very same configuration can be done in JSON format as well. So you don't actually have to write code. If you want to use the JSON format, you can do the exact same thing. So if I call this endpoint, I can assert that the response is indeed what is in the response.json. So this is still very simple. Cool. Then, what about proxies? So in this case, we do use this quite a lot, because what we don't want to do for every test is creating new signed headers or new headers that have some kind of context. We just want WireMock to do that always. So basically, I can put a pattern in here. So for anything that comes in this pattern, I'm saying add some context for me. And in this case, I'm just adding a header to it, and I'm telling it to proxy to another endpoint. What's going to happen? Of course, it's going to go to the port of 8080, where an application will be running in this test. It's also going to add the proxy prefix onto the endpoint, knowing that, oh, I'm going to have to send it somewhere where this application is actually running. And this part of the endpoint that I'm calling is going to be behind it, so that will always stay there. So what I want to do here is, when I call this endpoint here now, I want to assert, hey, did it add this header, and did it return whatever this application is returning? For which I have a very simple, the proxy endpoint configured. So it should land on this endpoint instead of the WireMock configuration, and the header should be there. Cool. So once again, what do we use this for? If you want to recreate the testing or chain testing or manual test environment that you have, and you're thinking it's using some components like authentication servers, you can implement almost all of that in WireMock actions, stubs, mocks, whatever. But of course, you cannot do everything with it. In general sense, your application most likely nowadays has some backend services, databases, caches, whatever, also configured. And of course, I don't even know if you can do it with WireMock, but you really shouldn't be doing that. So we have better ways of doing that. Of course, what we used to do, I'm using a database or something, and then we have an embedded database dependency with a test compilation running somewhere, and we have this feeling this works good enough for me. But what is the problem with that? We go to production with that version, and then, oh, the API that connects to this database, they're not compatible with the embedded version that we're using, because nobody ever updates an embedded database dependency. I don't think, whenever you update it, it just doesn't work anymore. So luckily for that, these days we have Testcontainers. So what they do is they allow you to run a Docker container, in this case, within your integration test, or any test for that case. Really doesn't have to be an integration test, using the actual version and database type that you are really looking for, that you can very easily keep in sync with the clients that you're using and the actual service that your on-premise or cloud environment is actually connecting to. And very easily can tell me, oh, this database is going to be updated to version this of the API. Does that work for me? Very simple to test. Update the test container version, it's going to work. So the demo that I'm going to show actually is not going to be like a SQL database. I found that to be expected, like SQL database, of course we all do that. What I'm going to do is in this case, I'm gonna use a Hazelcast vector database, which we use mostly for caching. But first of all, how do I know where to find which test container and how to work with them? It's very simple. It's all listed on the website of Testcontainers. There's a lot of modules which have even things like Docker Compose, HashiCorp, and other cloud-related services. A huge list of databases that are all implemented. It also runs on other languages but Java, so really not tied to only using Java. The example that we're doing today, in this case, is Hazelcast. So what do we have to do? I'm going to close some of the classes here. Hazelcast. So what we use Hazelcast for is, as I said, we use it for caching, and we use the Spring Cache framework for that to talk with it. Normally what we used to do before Testcontainers is possible is, a cache, this is really just a concurrent hash map, right? So what we would do is the bean that has the cache manager implementation, I just replace it with a concurrent hash map. Same problem, the actual caching operation might work because it's a hash map, but what if I change the version of the client? Oops. I now have to do manual testing again. Well, this way it is quite simple just to verify the version of the, let's say, the server that I'm gonna be talking to in production or test is just an image name, a Docker image name. And I'm gonna say, spin up a generic container for me using that version for that service. Cool, verify for me that it started. And then I'm gonna make a connection to the Hazelcast service that is running inside there. The only thing I need to do that is to ask it, hey, which port on my local machine did you end up connecting to? Because this is random. It's always random because the ports can, of course, be in use. So it always randomizes on each start which port is actually being used on my machine. The port here, this is the port on the container, which is always available there. But of course, on my machine is not the case. And the way Hazelcast works in this case, I can create a client out of this configuration, and the client is base material to create a cache manager again, which now I'm back at the cache manager level where I can test if I store any value in this cache or database, can I retrieve it again, is this working? So, whereas the actual part of storing the cache is really not very interesting, because that doesn't add anything compared to using concurrent hash map, because that's really just it's taken care of by Spring Cache. The only thing where I'm really interested here in is the version of the package of this compatible with that. That is really the only thing in this case that is important. You do need to have a Docker server running in the background to do this, of course. So you need to make sure the build server and your local host where you're running this actually has a Docker running. And it's going to start up the Hazelcast instance, connect to it. I don't think this is very interesting. No. Cool. So we have that done. So now we have basically most of the services that we generally would use in a chain or test or environment where we do manual testing. We have proper components taking care of making that environment as comparable as possible to that environment where we normally do manual testing. But of course, there is still a lot of problems here that pop up. So we've done this and we've noticed that now I'm going to do an update in my API, and I now have to ask the team who depends on me, can you please verify if this change that I did works for you? So we're still kind of doing manual steps, so it didn't solve that much yet. And that is where contract testing comes in. Contract testing is something I'm not doing as a provider of a service. I'm not actually doing it for myself. Yes, the idea of knowing my service works if someone defines consumer contracts is useful, but I do it mostly for them. They depend on my data. My service is going to work no matter what. I just want to know, without all this manual intervention, does this work? And we do that by defining contracts. So either the producer or a consumer in this case can actually start with the definition of the contract, but there has to be always at least a provider. The consumer is optional. The way this works, the provider defines an open API specification, the OAS, can be Swagger 2.0 in the case of the Pact flow.io that I'll show as well. But nowadays, open API specification is pretty well known already. So they will write the publisher test, which is basically based on the OpenAI specification, and they will publish that. We're going to have a look in the Pact flow how that looks like. But at that point in time, there is no information yet if my contract is compatible with someone using my service. And the way that really works, if you think about the WireMock stubs that I created because I'm using some service, basically what that is I basically upload that WireMock stub to as a contract and saying, this stub that I'm using, I need you as a provider to make sure this keeps working. So what I created that is the ability to say, the stubs that I have, I want to make sure that they keep working, because they're generally not updated very often, but the contract ensures that the stubs that I actually use as a consumer, that they are still guaranteed to work. And as a provider, I can simply test if that is the case, yes or no, but I just depend on people to actually define the consumer test. And then at the end, in this case, the application Pact flow can do a compatibility check, and it can tell you if you can deploy or not. And that works for both the consumer and the provider to do that. So Pact flow, in this case, we're going to look at some examples that we have here. This case, on the left, we have, most of it can be seen, it's okay. The left side is the consumer, and then to the right side of the, thank you. The right side of the infinite sign is the provider. In this case, a listing in here does not mean that there is a consumer contract. There should be, but there's not always. So that it can be that you are a consumer without consumer contracts. It's your responsibility as a consumer to tell the provider, this is what I expect you to verify every time you go to production.
What's the difference between using the protocol or Apple's key or something like this compared to the Pact flow?
I don't.
There is also similarities. You have versioning, you have a clear contract which is language independent and stuff like that.
I personally, I don't think it matters which tool you use, as long as you're able to do what you want to do. This is for us the choice that they made. I'm showing this open source tool, but of course the same idea can be or should be able to be implemented with whatever contract testing tool you want to use. I'm just showing with this tool because this is for us as being the choice to do. Where was I? So in this case, what happens when I try to verify the contract, I'm going to tell my test I am a provider for this application, and I need to configure a Pact broker. There's some configuration in the application for this, but there's a personalized access token in that, so I cannot show it, because that would show the key that I used to connect to that. I have an application running in the background, and there's one endpoint that in this case is basically a copy of one of the consumer contracts that I have. In this case, this is a service that returns a list of arrangements, so products, anything that could be within the bank. I'm going to tell Pact flow to start verifying the interactions that I have. So how does it know which interactions to test? Initially, all the verification will be, all the interactions will be checked. However, some of them or most of them can have a state configured that depending only when that state is active, the contract will actually be verified by that test. So it can be that I have 4 different contracts, and I make one test each verifying one of the contracts. In this case, none of them will be verified because I just removed this piece of code. And the one that one implements, I believe, is here. Yeah, it will say I didn't find a test with this state. So if I want to say, well, this test should verify this feature, basically, then run it again, and the test where this state is actually being defined will then actually be verified. That is what happens. All the other ones should then be covered by another test, basically. Cool. So in this one, what will I check? There's a matching body, there's a status 200. There is a headers content type also being checked, but it doesn't actually specify it in the step, so they could have added that to describe it, but it does expect this to be present. So it can, of course, once again verify all headers, endpoint status, anything. So in this case, what we've done is we have verified that our API that we have wrote meets the contract of one of the consumers that we have created. Of course, if I want to run the can I deploy, I need to do all of them in order to get a yes on that one. So in that case, I don't have to send a mail anymore, wait 2 weeks to get a reply. We need to plan in our backlog, etc., etc. I think still 8 minutes. But it's going to be the last part, so 3 minutes, I think. So A/B testing, which is what Simona was just hinting about. Luckily, she didn't show too much, because I did want to actually show a little bit how we do that. So once again, I think in 2 talks today, A/B testing was mentioned. The idea is it's sort of automated testing, but not really, because there's a lot of manual steps involved. However, the idea is experimenting. So I've done all these steps, but I'm working on a very big new feature, and I want to make sure that before 100% of my customers can contact it, I want to make sure I develop it smoothly, maybe even within a friends and family. What we've done is exposing only part of the feature. So step 1, 2 are there, and then it just stops, because I can experiment with it. So the way it works is I define an experiment which basically says there is a feature where a customer might have access, and there's a few ways to configure that. I can say, give it access to, no, this one seems to expire a lot. I can say, give it access to any customer who's part of this segment, which could be a friends and family, for example. But what I can also do is I can tell it, give 50% of the customers access to this one, and give the other 50% access to this one. Now what you then have is, back to design, how do I know which one works better? Well, have 50% of them use the other one, 50% the old one, and do some kind of like Google Analytics and see which of the two has more interactions in something that I'm doing. So, since I don't really have time to really demo in the application, but that's fine. What we've learned today is, well, 5 steps to go towards daily releases, basically. It's not like we have this implemented for all our applications, but some of them they are in some stage. If you have questions regarding what I've told today, or you want to connect, this is my LinkedIn. I will share also somewhere in the next few days, I will share the slides there. But connect if you want. And have a nice day for the rest. Enjoy the other talks.